Hi there, this is CC1 6th grade math lesson 1.2.4. Let's start with question 185. Use your multiplication table to figure out the missing number in each of the following number sentences. Each missing number is represented by n. So if you notice, there's an E tool. So let's write these down. And then we can use this E tool to help us as we work. So letter A is 15n. So 15 times some number equals 225. Let's check out this E tool. You might have used it during class. If you notice that as I hover over numbers, I can click on them and I can change the colors. So I can use different colors to mean different things as I do my work. So that's perfect. And then if I come up here to the corner, it'll say reset in the top right corner. I can click reset. So I know that 15 times some number equals 225. So I can't see 15 down here at the bottom. Actually, let me move this thing out of my way. Let's find 15 here at the bottom, and I can highlight the entire row. So I'm looking for 15 times what number is going to give me 225. So as I go across the row for 15, I'm looking for 225. And here I see it. And I will highlight it green so I know it goes with the green problem. So 15 times some number equals 225 in green. So I'm going to go all the way up and find out what number that is. Well, 15 times 15. So I know that n equals 15. And I know that because 15 times 15 equals 225. Perfect. Let's try the next one. Let's do letter B, which is 84 divided by 12 equals some number n. So let's clear everything, reset it. I know I'm looking at 84 and I need to divide it by 12. So I know I need to look at the row that deals with a 12. So I'm going to highlight that row and I'm looking for 84. So what's interesting is that you've got to know which number is on the inside and which number is on the outside. So the numbers that multiply, so what you called today, they're factors. The factors are on the outside. Oh, wow. That doesn't look like the word factors. You might have heard me use the word factor in your video yesterday with yesterday's homework. That is the preview part of review preview. So factors are outside, are on the outside edges. And I'm going to highlight that too, just so that I can kind of remember that. So I'm going to highlight it in red. These are my factors. The catch is that you don't necessarily have factors when you have division. So you have to be able to know which number's on the outside and which number's on the inside. So the product or the answer to the factors is on the inside. So let's get that and let's highlight that in pink. So it kind of matches that writing. Product is on the inside. So when you're looking, you've got this 84 is our product and the 12 is one of the factors. So I've got to figure out where 84 is in this row, and I found it right there. So I'm going to highlight it in blue. There's my 84. Now I need to move my toolbar. Now you don't have this problem. and I need to go find the top column, and I need to figure out what number that n is. Well, n equals 7. And I know that because 7 times 12 equals 84. So hopefully you recognize that the division is backwards of the multiplication. So let's do letter C and see if you can kind of piece that out. So this means my answer was a factor. Let's look at letter C. I'll do that in a different color. Let's do it in, let's say, orange. And this is 11 times something. So it has parentheses there around the end, but that doesn't really matter. It's just another way to write it. And I know that 11 and n are my factors. So I'm going to highlight that in red. Let's go back to my table, reset. And let's look at my 11, highlight the row, and I'm looking for my product, which is 143. So let's keep looking across, and there is my 143, highlighted in orange. Let's go up to the top, see if we can find its other factor. So you've got 11 times 13 gives you 143. So n equals 13. And I'm just writing this. They didn't ask me to write this, but I know that's because 11 times 13 equals 143. So I'm just writing that for my own knowledge. Let's do letter D. Pick a different color. Let's do purple. Letter D. I've got 182, and since this is division, I know that my factors were my n and my 13. So this was my product if I wrote it as multiplication. And these are my factors that I'm looking. So that's what I'm looking for on the outside. So let's reset my tool. Let's go find, I have an n on the bottom. So I can't look for an n row because that's not a thing. So let's look for the row that has a 13 in it. So let's click on the 13, highlight the row, and let's look for 182. So I'm going to look. Oh, look, there's 182. So I'm going to highlight it purple. I'm going to go all the way up, and I can highlight the column, and I can see that 13 times 14 equals 182. So n equals 14, and I know this because 13 times 14 equals 182. So multiplication and division are connected. Perfect. So that was 185. Let's move on to 186. Jack has 4 tiles and wants to find out how many different shapes he can make with them. So there's an E tool for this problem, but we'll see if we can figure it out. Sketch all of the arrangements that Jack could make with his tiles so that all of the tiles touch at least one other tile completely along a side. Period. Assume that no tiles can overlap. How many arrangements are there? So the E tool might be helpful because then I don't have to draw them all. Or if you prefer drawing, you can always draw. The E tool has 4 tiles available to you. And the nice thing is that I can just click and drag them and I can make my arrangements. So there's one arrangement. I can click on general tools. I could keep using these four, or I can just click and get some more tiles. They look a little different, but that's okay. So I can put one on the side there. And this might be quicker than you drawing. And see how I put it there on the bottom? I'm just going to go in the middle. I'm just going to work my way up on these edges here. I don't know how many patterns there will be. So that one's in the middle. So let's go to the top. I'm going to do the same thing, but I'm now going to like flip everything on the other side just so that I can see how these compare. I'm going to use the ones I've already created to help me create more. So there's my backwards L. And then I've got the one that looks like it's got a little nubbin in the middle. So I'm going to make it go the other direction. And instead of a backwards 7, I can make something that looks like a 7. Oh. So now the question is, are there other arrangements? They've all got to touch at least 1. So I've got 1 on a side and 3. So I think I've done all those different combinations of 3 and 1. Maybe try a 2 and 2. So I can do a box. Oh, but you know what could be fun? I can do another fun little arrangement of 2 and 2. They're all touching at least 1. So I can do that exact same thing, but opposite. Are there any other ones I can come up with? I can try to do that same kind of thing horizontally. I wonder if that counts as being different. And as you notice, I'm running out of space, so I'm going to zoom out a little bit, and that's going to get me some more boxes. You can't scroll over and to the right, so you just have to zoom out if you want a little bit more space, or move and delete what you've got. So I've done 2 and 2. The zigzag, these sideways ones that I made, these aren't really 2 and 2. This is kind of like 1, 2, 1. Oh no. Let's put that back. And then a 1, 2, 1. But I just kind of rotated these two, so that's okay. It looks like Tetris pieces. Let's see if we can come up with one more method. I think I'd like to do, they did 4 vertical, so I think I'd like to do 4 horizontal, if I can fit that on my board. So I think I've got all my different combinations. I've got a couple repeats that are just kind of rearranged a little bit. What I can do is I can create a screenshot and I can paste it into my document. If you're doing this at home on paper, you can draw these. If you want to save this, you can come up here in this corner on the top left and click save. And it will give you a link and you can bookmark this website. And so I want to click here to open the saved tool, and I can use my little star to bookmark it. And you can pick, like right here, I've got CPM tile problems. You can create a folder on your bookmark bar, and I can call this 186. If you need additional help with this, you can talk to any of your teachers, but I can call this. That's just a couple different things that you can do with these problems, and you can save them. So I can just click done. And then if I come over here, CPM tiles, I should see 186. And there is my problem all created for me. So I don't have to remember what I did. I can just pull it back up for my teacher. So I'm going to pause this for a moment. I'm going to copy and create a screenshot into my document, and then we'll be back to answer the rest of the problem. Okay, so I've got my screenshot made and I've got it entered into my document. You can continue to look on this page. You can see part B is right here. Or we can go back to the textbook and go back to 186 and read part B. For each diagram that you drew in part A, find the area, which is the tiles, and the perimeter, which is like the toothpicks. What do you notice? So I'm going to zoom in on all of these. And I know that the number of tiles is 4 for all of these. And so I don't really need to figure out different areas because all of the areas are 4. The area for all of them, which is the number of tiles, that's 4 units. And I can put a little square there for units squared because they are square units. Now, the toothpicks or the perimeter is what's going to be different for these. So let's start with the one that they gave us. So let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this has a perimeter of 10 units. Let's look at this next one that I made. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that one's got a perimeter of 10 too. Huh. That's interesting. I know that this one's also going to have a perimeter of 10 because these two are the same shape. They're just rotated or flip-flopped or reflected. So let's count the next one where I have like the little nubbin in the middle. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and 10. That one's also got 10. So I know that that one's also going to have 10 because that's the same shape, just reflected. And if you want to count, I would be willing that these two have the same number of toothpicks as those two. Because again, they're just different versions reflected or flipped. Similarly, with this one over here that's horizontal, that's going to have the same as the one that's vertical. So let's count this other one, this little 2x2 right here. So it's 1, 2, 3, 4, 5, 6, 7. Oh, this is 8. This has a perimeter of 8. Okay, so I know those are all 10. I can count these at the bottom. I should probably change my color just so that I'm a little less confused. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy moly. And so since these other ones are all little zigzags just rotated, that means they all have 10. So there's only one shape that has a perimeter of 8. And all the other different ways I can make shapes have a perimeter of 10. That's fascinating. Let's do 187. Write 4 different fractions that are equal to 1. Use your calculator to check that you are correct. Now, what's nifty here is they give you a calculator. It'd be great if you had one for class, but that's okay if you don't. Now, when you're thinking about fractions, what you want to remember is that fractions are division. So anytime I write a fraction, I want to use the division symbol on my calculator. And what's funny is that some calculators, it'll look like a slash, and some calculators, it'll look like a division symbol. So it could look like a slash, or it could look like this little division symbol that you saw in elementary school. Now, for a fraction to be equal to 1, it has to be able to divide by itself. So you can pick any number you want. So there's infinite answers here that are possible. But my favorite number is 27. So I am going to pick the number 27. And if I want it to be equal to 1, I know it has to be over 27 because any number divided by itself is equal to 1. And I can check it because I can do 27 divided by 27. And what's interesting is that it's a division symbol, but it looks like a fraction bar. And then this automatically tells me what it's equal to, but I can always hit enter. And sometimes, depending on how smart my calculator is, it'll let me scroll up. But this one doesn't look like it'll let me scroll up. So you can pick any numbers you want. I'll pick a couple more. I like 3. So I would do 3 divided by 3. That equals 1. And another number I like is, let's say 13. Let's do negative 13 even. If you know about negatives, it's just got to be the same number on the top and the bottom because anything divided by itself is 1. Perfect. Let's do 188. Copy and complete the table of multiples below. Count by 2s and count by 3s. So I need to copy this table down, and I need to write down all the numbers that appear in both rows. Describe any patterns that you notice. Okay, so I can, again, copy or do a screenshot and paste, but I'm just going to hand write this with a 2 and with a 3, and I can draw a horizontal line, and they give me 2, 4, 6, and here they give me 3 and 6. So I need to keep counting by 2s on the top. So you probably did this in elementary school, so hopefully you remember how to do this. It's 2, 4, 6, and then I can just keep going with an 8, 10, 12. I'm just adding 2 every time, so it's just the even numbers. 14, 16. Now the question is, how many times do they want me to go? So this would become 8, 10, 12, 14. Oh, I need to go one more after 16. So that would become 18. So that's the easier one. I got to do the 3s now, which might be a little bit more difficult, but that's okay. I'm ready. So after 3, I add 3 more, and that gets me 6. And if I add 3 to 6, I can try to do it in my head, or I can try to do a calculator, or I can just do 6, and I can count 7, 8, 9. Okay, so this is going to become 9. And then I can do that again. 9, 10, 11, 12. Okay, so this becomes 12. 13, 14, 15, 15. And I'm just going to keep using my little table as a little helper. 16, 17, 18, 19, 20, 21, 22, 23, 24, 24, 25, 26, 27, 27. Let's do letter B. Letter B. What is the smallest number that appears in both rows? This number is said to be the least common multiple of 2 and 3. So the number that they both have in common, so we want to find the smallest. And if you're looking at your table, it looks like 6 is the smallest that they both have in common. So I'm going to write down that 6 is the least common multiple. And we usually use the letters LCM. If you notice that you have this word here and it's written in blue, anytime you see a word that's written in blue in your book, it gives you a definition. So you can always click on those words if you don't know what they mean. Find 3 more common multiples of 2 and 3. So these won't be the least common multiple, but they will be a common multiple. Well, here's 12. I found 12. And it says find 3 more. Well, there's 18. That's a common multiple. What's interesting is that I don't have another one right now in my table. So I guess I'm going to extend it a little bit and see if I can find a third. So I'm going to continue my twos because my twos end at 18 and my threes numbers keep going. So after 18 would come 20. I don't see 20 in my threes. Let's go 22. I don't see 22 in my threes. I don't see 22 in my threes. Sorry about that. That was my dog. So let's keep going to 24. Oh, but look what I just found. You guys, I just found 24 and 24. Those are other common multiples. So I'm just going to write common multiples. Can you find the largest number that is a common multiple of both 2 and 3? If so, what is it? If not, explain why not. Do you think we could find the largest number? I do not, because as you know, I had to keep going with my twos. Both rows can continue indefinitely. Both rows I can keep going forever. So I cannot find the greatest common multiple. That's not really a thing. So I'm going to write that out. So I can keep writing both rows forever. There isn't a limit to how big I can go. There is nothing stopping me from counting. So I can't come up with the largest. Perfect. Couple more. Let's do 189. $189. How many hands long is your bed? Well, this is an interesting question. Using your hands as units of measure, first estimate, without actually counting, the number of hands that you think will fit across the length of your bed. So I can't really do this for you, but let's pretend like this is a bed. If you look at their picture, you notice you want your hands to go sideways as you're counting. So you're going to put your hands, there's one hand. Oh, this is going to be silly. And then there's two hands. So you're trying to guess how many hands will it take, and you'll alternate. So my hands would be like, this would be my left hand and my right hand. And then I'd put down my left hand and then my right hand. And I would keep going until I got all the way to the end. Like I know how to draw a hand. And I'm going to count how many hands I have. And then I'm going to do it in the other direction. So, for example, if I'm looking at my bed, I could say that I think my bed will be, I'm just going to estimate 15 hands by, let's say, 20 hands. And what's interesting is that it's going to depend on whose hands you're using as to what numbers you'll get. So now go ahead and get up and measure and record the length of your bed using your hands. So there is not really a wrong way to do this right now. You can just get up and go ahead and count and set your hands down one on top, one next to each other until you get all the way from one end to the other end. And then we are going to go on to 190. Write a whole number in the box for the fraction blank over 4 that makes it equal to 1. So I know that any number on the same on the top and on the bottom is going to give me 1, because any number divided by itself is 1. So inside this box, I need to put a 4. That's going to make it equal to 1. I want the same thing on the top and the bottom because there's 4 groups. I'm sorry. If I have 4 things and I split it into 4 groups, that's going to give me 1 thing per group. For letter B, I need it to be greater than 1. Well, if I want it to be greater than 1, I have to have at least 1 item for each person. So that means I need a number bigger than 4. So let's go with 5. That's just a little bit bigger, but it's still bigger than 1. Letter C, less than 1. So if 4 is equal to 1 and 5 is greater than 1, I must have to go in the opposite direction. So I need less than 1 thing per group. So let's pretend like I only have 3 things total. Okay. And then I've got equal to 0. Holy moly. If I want to set it equal to 0, well, that means if I have 4 groups I need to split it up into, and I want every group to get 0, that means I get 0 to start with. So if I have 0 things split up into 4 groups, each group gets 0. Letter E is greater than 100. Well, I know greater than 1 was 5, but this needs to be greater than 100. So I'm going to go with 500. And you honestly could have picked any number greater than 400, because 400 would have given it to you as equal to 100. So any number bigger than 400 will work for letter E. Let's do 191. Study the dot pattern below. So this looks like a diamond, and it looks like it's growing, and it looks like it's growing. Sketch the 4th and 5th figures. Oh, look, so here's an E tool. So let me close out all my other E tools that I've made today. Let's open up this E tool. And so this has the dots. So if you notice, there's a spot for figure 4. If I make this a little bit bigger, I bet I can find a spot for figure 5. So let me adjust my screen. Okay, so I made everything bigger, and I made my screen a little bit bigger so I can see the dots. The backgrounds, I'm not worried about the backgrounds right now. And I click on this, I got the general tools, so they do have the dots. So something you can do with your Chromebooks is you can click and drag these if you want to copy and paste them. So I can click my mouse, hold the clicker, drag it. I can Control C, click away, and Control V. And if you notice, you can see them kind of lined up right here, and I can put them right there. And that helps me out a little bit with making this a little easier to use these tools. So I can just copy down this next picture so that it looks like figure 3. Now the catch is I got to figure out what figure 4 is actually going to look like. So it looks like that this top part You can also long press on these dots. So if I click on it and I hold down, there we go. Okay. So if I click on it, I should be able to hold it down. Oh, it's not clicking for some reason. There we go. I'm going to click this and make it blue. So it looks like if I look at these blue ones on the bottom, it looks like it's getting longer by 1. And you can change these colors to help you. So if you don't have markers, because you just don't have markers with you, but you have access to the E tool, you can long press. So click on it and hold it. Sometimes it doesn't work. I don't know why. But I can drag this right here and drop it. And then honestly, the colors kind of pop up right there for me. So that kind of makes it a little easier. So I had 1 blue dot, 2 blue dots, 3 blue dots, 4 blue dots. Well, I'm going to do the same thing on the top. So I got to put a 4th on the top. And now to get figure 5, I can Control C and then Control V. And I can drag this bad boy over here, this bad girl over here. Well, I had 4 blue dots. So for figure 5, let's get 5 blue dots. And see, if you notice here, I can't really... There we go. Which means I should also put another dot at the top. It doesn't look like those dots on the side are doing anything. So it doesn't look like there's anything to change with that. So I'm going to, again, you can do a screenshot. I don't remember how to do a screenshot on your Chromebook, so you'll have to ask your teacher. Or you can click up here in the top left corner and click save. But I'm going to come over here and I can Control V this on my document. That way, everything is easy peasy. Now let's look at letter B. And it says, let's go back to the book so I can read it. It might be a little easier. Oh, I lost it. How many dots will the 50th figure have? So how many dots will the 50th figure have? So I'm going to move this back over and I'm going to get it out of my way. And I'm going to think about the pattern between how many dots I have and the figure number. So let's scoot this over a little bit. Okay, so I know that this blue portion was growing. And if I look at how it was growing, I noticed that the number of blue dots I had created matched my figure number. So I know that my figure 50 is going to have 50 blue dots lined up along this way. So this is going to have 50 dots. When you look in the middle, these 2 dots, they never changed. So I got a whole lot of nothing to do with those dots. So I'm just going to draw them. Dot and dot. And I noticed that the top matched the bottom. So all of these top halves matched this bottom half. Top dots and bottom dots. Top dots, bottom dots. And those matched the figure. So I'm going to have another 50 dots here on the top. And that's what my 50th figure is going to look like. How many dots is that going to have? Now I have to add these all together. So I've got 50 plus 50 plus 2. And that is going to be a total of 102 dots for figure 50. Perfect, everybody. Let's do 192. Write the prime factorization of each of the numbers below. So let's start with the number 24. And whenever you're figuring out factors, you're figuring out numbers that multiply to give you a specific number. Well, this number is 24, and you can start with any numbers you want. And I want to keep factoring until I end up with all prime numbers. A prime number is a number that only has 1 and itself as the factor. So if that's something you don't remember, that's something we should write down. So I'm going to take a moment and I'm going to think. And I'm going to remember that prime means it only has 1 and itself as factors. And the factors, as you know, you've been working on in class, those are numbers that multiply. So what numbers multiply to give you 24? You may start with different numbers than what I'm going to start with, but we're all going to end up with the same prime factorization. So a number I like to start off with is 2. So let's start off with 2. And if you need to, you can go back up here and scroll to this problem where it says the E tool for the multiplying, and you can save this if you'd like. Because I know that 2 times 12 is going to give me this 24, and that's what I have on this problem. So I know that it's going to be 2 and 12. Well, 2 only has itself and 1, so 2 is prime. If I want to keep going with 12, I can break that up into 2 and some other number. So I can look here. Oh, look, there's my 6, or there's my 12. So I can break my 12 up into 2 and 6. Well, I know 2 is a prime number, because when you're looking at this, another way to say it is, look, oh, there's only a 2 and a 1. There's nothing else that's going to give me a 2. That's the only place that it's at, so it's got to be prime. Okay, so let's keep going with the 6. The 6 is going to become 2 and 3. Well, we know 2 is a prime number, and if you look here, when you've got 3, well, 3 only has 1 and 3 as a factor. There's no other 3s on this entire board. So 3 is also a prime number. So your prime factorization is 2 times 2 times 2 times 3. So you've got 3 2s and 1 3, and that's going to give you 24. And if you're not sure, you can scroll down here to your calculator and you can work it out. So what you definitely want to do is you want to use the rest of the problems in your ebook to help you answer the problems in your ebook. And that's what I'm hoping to help you learn. So let's do 52. So let's start with 52. And I can reset my board, and 52. I can start with 2 and some other number, but I'm not sure if I know that. So I'm just going to look at my board for a while, and I'm going to see if I can find the number 52. There's the number 52. And I can find the factors by looking on the outside. So I've got 4 times 13. Well, hot dog, the only 13 I see has a factor of 1 and 13. So that means 13 is prime. And the nice thing about 4 is that 4 breaks up into 2 and 2, which we know already is prime. So my prime factorization is 2 times 2 times 13. So 13 is a little bit of a bigger prime number. And then we've got 105. So let's go back to our tool. See if you can find 105 on this board. Yeah, it might take you a minute, but I found it right there. And so I'm going to look at the row and the column for the factors, and I've got 7 and 15. Again, you can try to figure this out on your own. You can come up with some other numbers, but I have this tool, so I'm going to use it. 7, if I look for it right there, it only has 1 and 7, so that is a prime number. So 7 is prime. 15, I don't think is prime. Here's a 15 right there, so I can see that 15. And if I look at that row and that column, I can see 3 and 5. Now this is becoming a lot of rows and colors highlighted. So that's okay though, because I know that these are prime. So my prime factorization is 7 times 3 times 5. Looks like we have one more problem to do. 2 more problems to do. Let's do 193. 193 is a really important problem. Your teacher might draw attention to it in class. So you really, really want to pay attention to it. And the reason it's so important is because you have this, in fact, I'm going to put a sticker there, right there. You can see that that check mark is so important. So that means this problem is really important. We really want to focus on this problem. So let's read about why. Throughout this book, key problems have been selected as checkpoints. Each checkpoint problem is marked with an icon like the one at left, the check mark. These checkpoint problems are provided so that you can check to be sure you are building skills at the expected level. When you have trouble with checkpoint problems, refer to the review materials and practice problems that are available in the checkpoint materials. This problem is a checkpoint for using place value to round and compare decimal numbers. It will be referred to as checkpoint 1. Use your knowledge of place value to round the decimals to the specified place in parts A through C. Place the inequality sign, less than or greater than, in parts D through F. So we are going to do those parts and then we'll continue reading this problem. So let's look at letter A, 17. So when it says it's a checkpoint, that means at this point, I need to check, do I know how to do it? I should know how to do this. If I don't, I need to talk to my teacher for help. So 17.1936. You should know that the hundredths is the 9. And you are looking at the number next to the 9. Since it is below 5, my number is not going to round up. It is going to stay the same. So it's going to be 17.19. So look at the 3. If it's less than 5, the given place value remains. Let's do letter B. 0.2302. Thousandths. The thousandths place is the 3rd place. So let's look next to it. If it's less than 5, the given value remains the same. It does not round up, so it stays a 0. And I'm going to write it so they know that I rounded. And then finally, letter C. 8.256. Let's round this to the tenths. So let's round this to the tenths. The tenths is the 2. So look next to it. This is 5 or above, which means that I need to round the given value up. So this is going to become 8.3. So this is 5 or greater, which means the number next to it increases. Letter D. I need to place the appropriate symbol. So let's look at the place values. 47 and 2/10, 47 and 197 thousandths. So if you notice, 47 is the same. Then you notice there's a 2 here and a 1 here. Because the 2 is higher than the 1, that automatically means you have a symbol opening to the left, and the left is a greater than symbol. And hopefully you know that that's a greater than symbol. If you're struggling with that, talk to one of your teachers. Letter E. 1.0032. And now 1 point, and this has 3 zeros. 3, 2. So let's compare them. I've got a 1 and a 1. That sounds beautiful. I got 2 zeros, 2 zeros, and then I notice that this is a 3 and that's a 0. Once again, the number that is bigger, which is the 3, is greater. So here's another greater than. Which means I'm going to estimate that F will be less than, or I'm going to guess, but I don't really know, so I'm going to look. So let's look at our numbers. Starts with a 0, another 0, here's a 0, here's a 3. That means I need to switch it to the opening to the right, which means that this is a less than symbol. So let's go back and keep reading. Check your answers by referring to the checkpoint 1 materials located at the back of your book. Ideally, at this point, you are comfortable working with these types of problems and can solve them correctly. If you feel that you need more confidence when solving these types of problems, then review the checkpoint 1 materials and try the practice problems provided. From this point on, you will be expected to do problems like these correctly and with confidence. So please make sure you understand how to do this. If you want more practice, there's this link right here, and I can click on it. So I'm going to click on it. There we go. Okay. And you'll notice that this takes you to checkpoint 1, problem 193, and it will show you the answers. So I've got 17.19. So let me get my little pen out. I can check my own answers according with this video. So 17.19, 0.230, check. 8.3, check. Greater than, check. Greater than, check. Less than, check. So then what also happens is, in case you're like, hey, I need more practice, this book gives you some notes. It gives you some examples, more examples, and then it gives you some extra problems that you can go through. And it'll help you out. So then they give you some more examples and talk you through it. They give you some more problems with rounding and some more problems here. Then they give you more answers. This curriculum is very student driven. If you are confused, you need to speak up. Please know that these materials exist and they are here to help your learning. These checkpoints are here for your learning and what you should know at that given moment in your class. Your teacher might even put these on a test, but that's going to depend on the teacher. So please talk to your teacher about how they will use these checkpoint materials. Thank you and have a wonderful day. Thank you.